Good morning, good afternoon, good evening. Welcome back to Chapter 1. Darwin, a name you've probably heard for quite a while. Darwin published a book called On the Origin of Species by means of natural selection. He published it in 1859, a very long time ago. His book had two main points. All of the species on the planet today came from an ancestral species that's no longer here. It's referred to as descent with modification. Descent with modification means the parents pass genes on to kids, and the kids are a little bit different from the parents. The second major principle was this process referred to as natural selection. Natural selection says some individuals do better in the environment because they have traits that allow them to do better. Because those individuals do better, they have more children. They pass those good traits, genes, on to those kids. Because they have more children, the next generation will have a higher percentage of those good traits. That's evolution that we just talked about, change in gene frequency. Because they had more kids, then the more of the next generation belongs to them, and those traits will be in higher frequency. And that's what natural selection is. Natural selection. You have to survive today to have babies tomorrow. If you can't withstand today's circumstances, then you don't have babies tomorrow. Nature has selected against you. But if you do survive today's circumstances, then you can have babies tomorrow. Nature has selected for you. Natural selection has selected that you get to go on. Darwin's observations led to a number of principles. The first principle is that individuals have unequal reproductive success. What this means: some individuals have better traits than others. Because they have better traits than others, they will have more kids than others. And let's pause. When I'm saying all of this, you're probably thinking of people. Some people have better traits, and therefore they're going to have more kids. And it's like, well, that's not true. I know a moron that's got like 6 kids. That doesn't mean anything. Don't think of it in terms of people. Think of it in terms of wolves. Think of it in terms of squirrels. Think of it in terms of geese. Okay? Those individuals that are better able to survive the environment, those individuals that are better able to gather resources, to defend a territory, to find shelter, are going to do better. What allows them to do those things better? They have better traits. Traits that are better suited to this environment. Because they have those better traits, they're going to be able to survive better in this environment. And because they do, they're going to leave behind more kids. That's what natural selection. And it also is unequal reproductive success. If everybody has the same chance to have kids, then there is no natural selection. Certain traits aren't getting weeded out, and other traits aren't being amplified. They're not being selected for. But that's not how the case is. It is the case that some individuals don't do well, and they die and don't have kids. Some individuals do really well, and they have lots of children. Unequal reproductive success. Natural selection depends upon unequal reproductive success. Accumulation of favorable traits over time. We just said that. If you survive today, it means that you can survive today, and therefore you can have babies tomorrow. As time goes on, those favorable traits will accumulate in a population. And that allows that population to live very well in that specific area. And each area is different, which is why we have so many different species. Beneficial traits, beneficial adaptations will accumulate, will build up in a population over time because of unequal reproductive success. Only the ones who did best in that environment survived. Here we see a bunch of bugs. Remember, we said that life requires variation. The bugs have a range of colors. Some are really pale, some are really dark, some are in between. Natural selection. A bird sees these bugs. Which ones are going to be the easiest bugs for the bird to see? The light ones. So the bug is going to eat the light ones because they're the easiest to find. If I have reduced the percentage of pale bug genes in the population, that is evolution. The bugs that were pale had an unequal reproductive success. They weren't allowed to reproduce because they got eaten, because they had traits that were not beneficial to the present environment. So if we allow that to continue over several generations, then what we get is darker bugs. Bugs that better favor this environment. Unequal reproductive success leads to natural selection. Natural selection leads to a change in gene frequencies over time. We've got 25% pale bugs and we have 50% dark bugs. Now we have all dark bugs and no pale bugs. The pale bug gene has been removed from the population, reduced, changing gene frequencies. That's evolution. Many small changes in a population lead to major changes in a species over many generations, and usually it's like many thousands of generations. A few small changes each generation. Compile that times 1,000 generations. Suddenly that's a bunch of major changes. That's how we go from one species evolving into different species. Many small changes over thousands of generations. The fossil record is full of species that changed. Species that did well in their particular environment. The environment changed, and because the environment changed, the species that live in that environment have two choices: change with it or die. And it's really more of a case, it's not that, okay, the environment is pale, so I'm pale and therefore I blend into the environment. Oh, the environment is dark now, so I'm going to get darker, so I blend into the environment. And that's not how it works. The individual didn't change. The individual bugs didn't, this pale bug did not become darker. What happened to that pale bug? It got ate. And because it got eaten, the population got darker. And because only dark bugs survived today, who was available to have babies tomorrow? Only the dark bugs. And if mommy is dark and daddy is dark, what color is baby probably going to be? Baby is probably going to be dark. Species change. This is an assemblage of species that lead to modern day elephants. We've got quite a good assemblage of them, and we see that species change. Look at the different tusks. You really need to look at this on your own, because you got to look at the Platybelodon, because that guy had a really rough time in school, and you just need to look at this dude, the light blue one, and just be glad you weren't a Platybelodon. Just saying. Species change over time. We start with very different animals and end up with similar, but we end up with modern day elephants. Species change over time.